The most recognizable structure in our solar system is dying, not in millions of years, not theoretically, right now. Saturn's rings, the ones every child has drawn since 1610, are falling into the planet at a rate of 3,000 kilograms per second. And what NASA found during Cassini's final mission has changed everything we thought we knew about how they got there. This isn't speculation. In December 2018, a research team at NASA's Goddard Space Flight Center, led by Dr. James O'Donoghue, published findings showing that Saturn's rings are losing mass faster than any previous estimate. The rate is so high that the rings, in their current form, will be unrecognizable within about 100 million years. Some sections may be completely gone in 50 million. By cosmic standards, that's tomorrow. But the bigger question isn't when they disappear. It's how they got here in the first place, and why they're young enough that the dinosaurs may have looked up at a Saturn without rings. Galileo Galilei first saw Saturn's rings through a telescope in 1610. He didn't know what they were. They looked like ears or handles. It took 50 more years before Christian Huygens correctly identified them as a flat disk surrounding the planet. For 300 years after that, scientists assumed the rings were as old as Saturn itself, formed during the same chaotic period that built our solar system 4.5 billion years ago. The rings, in this view, were just one more permanent feature of the planet, like its color or its shape. That theory held until Cassini. The spacecraft launched in 1997, arrived at Saturn in 2004, and spent 13 years orbiting the planet. It returned over 500,000 images and 450,000 scientific measurements. And what it discovered about the rings has rewritten every textbook chapter on how planets form. The first surprise was the rings' composition. They are 99.9% water ice, pure, clean, unweathered ice. If the rings were billions of years old, they would be heavily contaminated with dust and meteoritic debris. They're not. The ice is too clean, which can only mean one thing. The rings are young. How young? Cassini's mass measurements, finalized in 2019, suggest the rings formed somewhere between 100 and 400 million years ago. To put that in perspective, dinosaurs roamed Earth 240 million years ago. There is a real possibility that early dinosaurs looked up at a Saturn that had no rings at all. That alone broke the mainstream model. But here's where it gets stranger. The phenomenon called ring rain was first detected in 1980 by Voyager 1, but it was Cassini that measured how severe it actually is. Charged ice particles from the rings are continuously falling into Saturn's upper atmosphere, pulled in by gravity, accelerated by Saturn's magnetic field, and burning up as they enter the planet. The rate is staggering. 3,000 kilograms of ring material falls into Saturn every second. That's enough to fill an Olympic-sized swimming pool every 30 minutes, and the rate is accelerating. But here's the part that doesn't fit any clean model. The amount of material falling in does not match the rings' total mass divided by their predicted lifetime. Something else is happening to them, something subtractive that ring rain alone can't explain. Dr. James O'Donoghue is the planetary scientist whose team's 2018 paper became the foundation for the modern understanding of ring loss. He has been remarkably direct in interviews. In a 2024 statement to the Royal Astronomical Society, he said the rings are almost certainly a temporary feature, and that humans living on Earth right now are witnessing the end of one of the universe's most beautiful structures. Dr. Linda Spilker, who led Cassini's mission throughout much of its operation before moving to Voyager, has been more cautious. But in a 2025 lecture at JPL, she made a comment that did not go unnoticed by other planetary scientists in the room. She described Cassini's final dive between the rings and Saturn's atmosphere as containing data sets we are still actively interpreting. The mission ended in September 2017. 8 years later, parts of the data are still not public. Dr. Jeffrey Cousy, one of the originators of ring science at NASA Ames, has stated that the rings are an astronomical accident in progress. That phrase is worth pausing on. He doesn't mean accidental in a casual sense. He means that the existence of the rings at this exact moment in cosmic history is a coincidence so unlikely that humanity may be the only intelligence in our solar system to ever see them. There are 3 serious theories about how Saturn's rings actually formed, and which one is correct changes everything. The first is the moon-shattering theory. Approximately 100 to 200 million years ago, a small Saturnian moon, somewhere between 200 and 400 kilometers across, was shattered. Either by a comet impact, by tidal forces pulling it apart, or by some unknown event. The debris settled into the orbital plane and became the rings. This is currently the leading mainstream theory. The second theory is comet capture. A massive icy comet, perhaps 100 kilometers in diameter, ventured too close to Saturn and was torn apart by gravity. The fragments dispersed into a disk. This theory is older, but has been gaining renewed support since 2024 modeling studies. The third theory is the one most scientists won't write papers about, but discuss in private. That the event that created the rings was unusual enough that it cannot be fully explained by either a moon shattering or a comet capture. That something specific happened around Saturn relatively recently, possibly when complex life was emerging on Earth, and we are looking at the aftermath. What strengthens the third view is the Cassini final dive data. The spacecraft passed 22 times through the gap between Saturn's atmosphere and the innermost rings. It detected unexpected magnetic field structures, atmospheric chemistry that didn't match models, and ring particles with size distributions that don't fit either of the first 2 origin theories. JPL's full data release is still pending, ostensibly due to the complexity of the analysis. The interpretation in some quarters is different. Here's what we know for certain. In March 2025, Saturn's rings briefly appeared to vanish from Earth-based telescope view. This wasn't supernatural, it was geometric. Saturn's tilt brought the rings edge on to our line of sight, making them temporarily invisible. This happens approximately every 15 years. But this particular cycle drew massive public attention because it coincided with growing news coverage of long-term ring loss. That news coverage focused on ring rain. What it didn't focus on was the smaller, weirder finding from late 2024 that the inner D ring is showing structural changes that are not consistent with steady decay. Some sections are losing material faster than others. Some sections are gaining brief transient density spikes that look almost like waves moving through the ring plane. The European Space Agency's planned 2030s mission to Saturn, called Enceladus Lander, will pass through the ring system. Its instruments include a high-resolution imager and a particle composition analyzer. It will be the first up-close ring measurement since Cassini. By the time it arrives, the rings will already have lost trillions of additional tons of material. We are watching them disappear in real time. Here's what matters. Saturn's rings exist for a brief window in cosmic time. They were not here for most of Earth's history. They will not be here for most of Earth's future. The fact that humans evolved at the exact moment the rings exist, looked up, invented telescopes, and got to see them, is a coincidence that staggers most scientists when they think about it. If the third theory is correct, if the rings were created by something we don't yet understand, then their disappearance may also follow a pattern we don't understand. The slow loss could accelerate. The structure could collapse faster than predicted. Or, more disturbingly, it could be a sign of something else entirely, something the original ring-forming event left behind, still influencing the system, still pulling material in directions our models don't predict. The most beautiful thing in the sky is also the most fragile, and we may be the last generation of humanity that gets to study it whole. The next Ring Edge On event will occur in 2038. By then, ground-based telescopes will record subtle changes in ring brightness and density compared to today. If any of the third theory predictions are correct, those measurements will be the first warning sign. If you want to know what scientists find when they get a closer look, subscribe. And if you thought Saturn was strange, wait until you see what Voyager 1 has been sending back from interstellar space. The video link is right on your screen.